Earth was formed about 4.65 billion years ago. Scientists use the geologic timescale to describe events that have happened throughout Earth's history. If the entirety of Earth's history was represented on a clock, humans would appear at 11:59:48. At least 3 times in Earth's history, the planet was engulfed almost entirely in ice, an event called Snowball Earth. These events happened between 580 and 750 million years ago. Evidence for Snowball Earth comes from sedimentary rocks. In a normal ice age, the types of rock deposited by glaciers would be found mostly near Earth's poles. However, geologists found glacial rocks of similar ages around the world at both the poles and equatorial regions. This led to the Snowball Earth theory. Snowball Earth was caused by a chain of events called a positive feedback loop. Ice has a high albedo and is very insulating, so it is not heated up efficiently by sunlight. As ice accumulated on the planet, it increasingly reflected more sunlight and cooled Earth even further. Thus, this created a cycle of ice formation, increased albedo, and cooling of Earth, which continued until the entire planet was covered in ice. Why is Earth not covered in ice now if the positive feedback loop continues forever? The leading theory is that volcanoes continued erupting during Snowball Earth, emitting high levels of carbon dioxide, which was trapped under the ice. Eventually, the carbon dioxide built up enough to start melting the ice. Ice turned to water, which has a lower albedo and thus absorbed more of the sun's energy. This led to a new positive feedback loop that resulted in warming of the planet and the end of Snowball Earth. Additionally, it is believed that bacterial life on Earth survived the harsh conditions during Snowball Earth events by living near the heat sources from volcanoes. Due to plate tectonics, Earth's land is constantly shifting and changing over time. 250 million years ago, all of Earth's landmass was united in a single supercontinent called Pangaea. About 200 million years ago, this supercontinent began to break up into pieces as the plates moved away from each other. Smaller land masses were formed until, eventually, the continents we recognize today were shaped. It is easy to see how certain continents, like South America and Africa, once fit together. Even today, the location of the continents continues to fluctuate. Scientists theorize that a new supercontinent, called Pangaea Proxima, could form 250 million years in the future. Proposed by scientist Alfred Wegener, the theory of continental drift was one of the earliest ways to explain why continents moved over time. Wegener noticed that the shape of Earth's continents, such as South America and Africa, could fit together like a jigsaw puzzle. He also studied fossils from different continents that showed the remains of identical plants and animals spread throughout the world. For example, dinosaurs lived during the Triassic, Jurassic, and Cretaceous periods. As Pangaea broke into different pieces, fossils show that dinosaurs spread to different continents and evolved into different species over time. Based on this evidence, Wegener theorized that all of Earth's continents were originally united in the supercontinent Pangaea. Over time, they drifted apart to their current positions.